Quadratic Inequalities by Bobby, Raphael, and Manali. Graphing manually through standard form. First, you get your equation, and then you find the vertex using negative b over 2a. Then you substitute the values for negative b and a. Then you make a table. First, you put the vertex in the center and choose 2 points both above and below the vertex to ensure you have the curve. Then you graph those points on a graph and shade depending on whether it's greater than or less than. Since it is not greater than or equal to, it is a dotted line to show that the points are actually not solutions. Another example of graphing from standard form is using the equation y is less than or equal to x squared plus 3x plus 4. First, you would find the vertex using negative b over 2a to find the x-coordinate of the vertex. After substituting in the values from the equation, I got 1.75. Then you substitute this value in again back into the equation because this is the x value for the vertex. And there's the vertex point. Then you put that value into the table, again in the middle, finding 2 points both above and below the vertex to get a curve. Once you find these values, plot them in on the graph, and then connect the lines. I use a solid line because it is less than or equal to, meaning that these lines are actually points on the solution.
Okay, quadratic inequalities in vertex form. Vertex form can be recognized by parentheses or no b-value. This inequality, negative x squared plus 4. First, what you do is you find the vertex. You can see here and right here. Then you make a table with the vertex in the middle, like Manali said. Then you use the points you have in the table to graph it. Because this is not equal to, you have a dotted line and you shade on the outside. This is our second example. Y is greater than or equal to negative x squared plus 4. Because it's greater than or equal to, you shade on the outside and the vertex is 0, 4. You make the table and then you graph it. Because it's equal to, it's a solid line and you shade on the outside of the parabola. Now we are graphing. This is graphing with technology. So first thing you do is you put in the equation. This is negative x squared minus 2x minus 3. Then you hit the graph. Because you can see the graph, you don't really have to do anything to adjust your window. If you want to find the vertex, you hit second, calc, go down to maximum, because it's a maximum. You arrow over to be left of the vertex, hit enter. You arrow over to the right of the vertex, hit enter, and then hit enter one more time. As you can see, it's not exact, but you can round it to -1, -2. So that's the vertex of the parabola. And if you want to shade, because we can see that it's greater than or equal to, you go to y equals, over, hit enter, enter. This shows that it's shading on the outside. Then you hit your graph, and it shades it in for you. Okay, now for our second example. To clear your data, you can go second, memory, 712. Then you go to y equals again and put in your next equation. Negative x squared minus x plus 6. Then you go to the graph. As you can see the vertex and most of the parabola, so you don't have to adjust your window. You use the same keystrokes to find the vertex. And it's -0.5, 6.25. Now if you want to find the x-intercepts, you hit second, calc, go down to 0, then you arrow over to be left of the x-intercept, hit enter, arrow over to be right of the x-intercept, and hit enter. So the x-intercept is -3, 0. To find the other one, you do the same keystrokes. And then it's 2, 0. Okay, so now we're going to teach you about shading. This shading is for the inequality y is greater than x. It's not equal to, so it's a dotted line. And since it's greater than, we shade in here. Now, this is y is less than x. It's not equal to, so it's still a dotted line, and we shade on the outside. This one is y is greater than or equal to. It's greater than, so it's a solid line, shade on the inside. Y is less than or equal to x, solid line, shade on the outside.